So today we're going to be looking at quadratic inequalities. So just put the screen in a better place where I can see it. So everything set out properly. There we go. That's better. So we already know how to solve a linear inequality. Something of the example 2x plus 7 less than minus 4. So we'd expand the bracket and then we would add, take away 14 from each side, is going to be minus 18, so x will be less than minus 9. And we can do something like this, 11 minus 2x plus equal is greater than or equal to 5. I'm going to take 11 away from both sides, greater or less than minus 6. And now we're going to divide both sides by minus 2. Okay, and when we do this, when you divide or multiply both sides by a negative number, you switch the direction of the inequality. So it's going to be minus 6 divided by minus 2 is going to be 3. And that is a rule for inequalities that you need to be mindful of when solving them. If we multiply or divide both sides of an inequality by a negative number, then the inequality sign must be reversed. Now this becomes important if we have something like, say, 2x minus 4 over x greater than or less than 7, because to solve that you would multiply both sides by x, but because x is a variable, x could be a negative number or it could be a positive number, so we'll then get ourselves into some trouble by solving this inequality, because it could be positive or negative. That's just something to bear in mind. Now we're going to solve 2x minus 5x minus 14 is greater than 0. So for this, we're going to sketch a graph so we can see where which values this will be true for. So we're going to set y equals 2x x squared minus 5x minus 14. So we're going to look at when y equals 0. So x squared minus 5x minus 14 equals 0. We'll factorise this. We have x will be minus 7 plus 2 equals 0. So x equals 7, x equals minus 2. So let's start to draw this. So we know it crosses the x-axis at plus 7 and minus 2. So it's going to come like this, and then it's going to be a minimum. It's going to be somewhere round about there. When we're trying to solve the inequality, we don't need to worry about where the minimum value is, because you see, we want to know when is this greater than 0. So we want to know when it's above the x-axis, y is greater than 0. So this is when it's positive, and this is when it's positive. So the solution is when x is less than -2 and when x is greater than 7. Let's look at another example. We're going to solve 2x squared plus 3x less than or equal to 27. So rearranging, we'll get 2x squared plus 3x minus 27 is less than or equal to 27. So again, we're going to make this for when y equal 2x squared plus 3x minus 27 and sketch this to look at the values for when this inequality holds true. Oh, sorry, that's meant to be 0. Sorry. So y equals 0 when? So let's factorise this. So we're going to have 2x and we're going to have x. So we're going to have plus 9 minus 3. 9 times 3 is 27. That's going to be times by the 2, and that will then give us a 3 equals 0. So x will be minus 3, plus 3, 9 divided by 2, sorry, that's going to be, so our x is going to be minus 4.5. So let's draw this. Again, we know it's got a minimum, not a maximum, because our coefficient of x squared is positive. And so we're going to have minus 4.5, and we're going to have plus 3 over here, and it's going to come down here and then up here. So this is negative, this is positive, and we want the inequality to be less than or equal to 0. So it must be x must be between the values minus 4.5 and 3 for that to be the case. So I hope that helps.